Hello guys, welcome to Academicus. Today in this lecture I'll be explaining example of steel truss design. So in this lecture I'll be just explaining the basic modeling. I'll be focusing on more the loads assigned and why those loads are, the calculation of those loads and analysis, and I'll show you the result in this lecture. So first I'll go through this truss model. So this truss is having a span of 18-meter span. The center is half span is 9 meter. The height of the rafter is 2.5 meter. That is, this cos theta is around 15 degrees. So this is the geometry of truss. I have just divided into 6 parts: 1, 2, 3, 4, 5, 6 on each side. This truss is spaced at 6 meter along x direction. Like, this is the length of the along the length of the building. So along this length x direction we have this truss spaced at 6 meter. Like, at every 6 meter we have this truss. So this is the basic general description of the truss. So let's get into the loading of this truss. So this truss will be designed for wind load, dead load and live load, and also there is snow load. So if you have snow, if your region comes under snowfall, heavy snowfall, or mild snowfall, or even low intensity snowfall, so you can just refer this design. So just let's get into the loading immediately. We'll just go through it. Modeling, I've already uploaded a video on how to model a structure in Staad Pro. I've also explained how to assign the loadings: dead load, live load, seismic load. Wind load is this truss. We generally assign nodal loads, so we can just assign the nodal loads. You can refer the nodal load assignment. So for that wind load, I'll be explaining how I've calculated those loads. So let's get into the loading. So I have a dead load. So these self-weight, these are your snow loads. This is also snow load. This is your dead load of roofing and your purlins. This is also dead load of roofing and purlins. So you can just have a look at this. This is the snow load. This is also snow load, which is acting only on the edge. So this is half. I'll be explaining why this is half of this, why this is half of this. So let's just go through this load. Live load, we have live load on the roof truss. This is 5.5 kilonewton and 2.75. Wind load, z direction and y direction. So I'll just explain. So these are the loads, and then comes your load combination. So you can have an auto load combination as per whichever standard you are following, or you can just assign your own load combinations. So let's get into the loading. So just click on Staad editor. I'm not showing the load calculation in a separate Excel sheet or anywhere. I just explained it using Staad editor. So you'll be also getting benefit of learning how we use Staad editor. So we are not talking about seismic loads. We are just talking about dead load, live load and snow load. So snow load I have considered as a dead load case. So just first case is self-weight. Self-weight, you don't need to assign anything. You just the coefficient -1. So let's talk about the snow load. Snow load, we have an intensity of 1.5 kilonewton per meters. So the inclined length of truss, the top chord has a length of 9.34. The bottom chord we have 9 meters, since because that 9 meter is your space, center half space, half truss length. So the truss spacing, we have 6 meter truss spacing area. So 9.34 into 6 meter, that is 56 kilonewton, 56.04 kilonewton per meter square. So snow load on intermediate point, we have intermediate point and end point. So the intensity is 1.5, the area is 56.04. What we have divided it by 6. When we talk about intermediate node, we have divided by 6. So how many intermediates? So which are the intermediate nodes? These are the intermediate node: 1, 2, 3, 4, 5 and 6, and this is your end node. So 6 intermediate nodes, that's why we have divided it by 6 So it is coming around 14.01 kilonewtons. So if you'll observe the structure carefully, you can see this on the end point you have only one span load being transferred, but on the intermediate node you have loads from this span as well as this span transferred. So we have just divided the load of intermediate node by 2 and applied on the end point, that is end node. So 14.4 kilonewton total snow load as a dead load case applied on intermediate and 7.0 kilonewton at end node. Similarly, your dead load of GC sheeting or whichever sheeting, roof sheeting you are using, you just take the intensity. So GC sheeting we have 150 kg per meter square, so that is 0.15 kilonewton per meter square. Self weight of purlin at 1 kilonewton per meter square. So total dead load will be 0.15 for GC sheeting plus zero point 0.1 for purlin. So which is coming around 0.25 kilonewton per meter square. Area we have 6 into 9.34, 56 kilonewton. Total dead load 0.25 intensity into area 14 point. So this 14.01 for intermediate divided by 6 is 2.34. For end node it is 1.17. So we have applied negative 1.17 on intermediate end nodes and minus 2.34 on intermediate nodes. So this is the dead load case for GC sheeting and purlin. Now let's talk about the live load. So live load, we have live load on the truss, live load on purlin per meter. So live load on truss, we have a live load of 0.563 kilonewton per meter square, purlin 0.563 into that purlin length. So per meter, so 1.8 is the length of the purlin, cos 15 is the inclined angle. So it is coming around 1 kilonewton per meter. So live load on half of the roof truss. Half of the roof truss we are calculating, it is for half of the roof truss, that is only one side from center. So 0.563 into 9.34 into 6, it is coming around 31.55. Total live load including purlin 1 for purlin and 31.55 for your roof live load on roof truss. So it is 32.55. So live load per intermediate node. So we have 6 intermediate node. So we have 6. This is wrong. We have 6 here. It should be 6. So we have 6 intermediate nodes. 32.55 divided by 6. It is coming around 5.5 kilonewton. Live load per end node. So end node divided by intermediate load divided by 2 is equals to your end node load. So hope this live load and dead load is clear. Now let's get into the wind load calculation. Wind load we are applying as a point load. So wind load, you have to first calculate the CPE and CPI, the coefficient of external pressure and internal pressure. So in our case we have one, the CPE plus CPI. 1 wind pressure 0.45 kilonewton per meter square. Area, exposed area, we are talking about half of the span. So 9.34 into 6, so which is coming around 54.04 meters square. So wind load, total wind load will be wind intensity into your area. Pressure into area is total load. It is 25.22 kilonewton. So wind load on intermediate node 25.22 divided by 6. Wind load on end node 5.2 divided by 2. So resolved wind load is just z direction 52.2 5.2 into cos 15 is theta y sine. So x is z, we have cos 15, y we have this. So wind load, live load, dead load is done. Load combination, you can as per your standard, I've used British standard BS 5950, these load combinations. So you can have your own load combination as per your specifications. You can have your own load combination as per your codes. So you just need to you have an auto load combination options, so you can just do that auto load combinations. So now just we have assigned, so I'll just show you those loads. So for dead load, self weight is assigned to a whole structure, self weight is assigned to whole structures. So I've said 14 kilonewton, that's no load at intermediate nodes. So these intermediate nodes have 14. When you click on 7, it is acting only on your end nodes. Similarly, for this is for your live dead load for your GC sheeting and purling. Intermediate load, this is very small, that's why you cannot, because this intensity is more. It is this much 2 point, and this is acting only here. Live load again on intermediate, and this wind load, as I said, 5. This is as per Z direction. Wind is acting on Z direction and Y direction. So look at the wind, Y direction and Z direction. X direction we are not applying. So Y Z direction. This is for your intermediate nodes, and this is your for end nodes. Again minus Z, minus Z. This is plus Z for intermediate nodes. This is plus Z end nodes. This is minus Z intermediate node. This is minus Z end node. This is a Y for your intermediate nodes, and this is Y for your end nodes. So this was your loadings. So once your loading is done, just click on analyze. The Staad editor is open, so you cannot just analyze. You close this. So we have just closed Staad editor. So just click on analyze, run analysis. So once your design is analyzed, you'll just get the results output. So this is analyzed with 13 warnings. Warnings are okay, but if you'll get errors, you cannot proceed further. Warnings are okay. So go to in the post processing mode, click on done. So once you get into the post processing mode, you are asked to select these. So we are not designing for individual load cases like dead load, live load and wind load. We are designing for load combination. So just select these, just take this on the left hand side, available. We have these available options. So just click on the load combination, because we are not designing for an individual load. We are not designing, any structure is not designed for individual load case. It is designed for load combination. So just select those load combination and click on this. We have these 3 load combinations. So once you click on this, you'll be getting these designs. So you have this beam. So if you click on this members, if you click on beam forces, you'll click on this member, you'll get the forces, the FX, FY. Moment is 0 because we have designed this as a truss. The supports, I have not discussed about the supports. I'll be discussing more about the supports. One support is your pinned and other is your fixed butt. What is fixed butt? I'll explain in the next lecture. So these are the forces. If you click on these are the forces. You want to check if the members are failing or if your members are passed, you can just click on the unity check. It will give the utilization of the members. So like these members, you have the utility normalized. I have allowed 90% utilization. So if your structure, if your member is being utilized more than 90%, then it is, I'm just kept it as it is a failing. So mostly it is 1. The ratio is 1, so you cannot exceed 1. So some members it has exceeded 1, like this member 1.203. It is this member 1.203. So once this member is failing, it will show which clause it is failing. So you can just revise these members. The general concept is you keep these members. If you are using angle section, you use a double angle section. Like if you are using ISA equal angle section as per Indian standard 75 75 6, you try using it 1996, or you can try using 265 65 6, or whichever section you need. So this is regarding the design. You can just revise the design, you can revise the member, and you can just get the normalized ratio allowable should be less than which you require. Like my requirement is I cannot allow the utilization of member more than 90%. So I've kept it as 0.9. If you want to utilize full 100% or 95%, so you can just change this during your analysis stage. Your failed members will be these members are failing, so these two members, it is showing that these two members are failing. So hope you have understood this example, design example of a truss. So in case if you have any doubt regarding a truss design, in this design I'll try to clarify all your doubts. We'll be coming up with a step by step a truss design problem, where I'll be just modeling first. I'll be then assigning loads, then I'll be analyzing the structure. But this lecture, I think it is very clear. We'll take a few more examples, but this lecture, I think it is very clear. I've already uploaded a video on the truss Staad modeling. I've already uploaded a video on how to assign loads. So if you go through those videos, then you can do it by your own. I have just in this video, the focus is more on loads, which loads we are taking on this truss, how those loads are applied, and where those loads are applied. For designing, for conceptual design, you just go through a truss problem, like which is what is the limitation of that, this angle, this theta, what is the limitation of this theta. You cannot just randomly just take this value. You can take 3.5, 4.5. That will be as per the theta limitation. So while designing, please keep that in mind. So thank you, have a nice day, and please subscribe to our channel and keep sharing our videos. If you have any doubt, you can anytime ask your doubts. We will try to clarify. And please press the bell icon so that you can get continuous notification regarding our uploads. Take care. Goodbye.